Good morning, good afternoon, or good evening, wherever you may be, and whether you're watching live or archived. And welcome to, I was going to say a TTT, we're in the wrong week, wrong day. This is a Nautel webinar Wednesday, and it's a product launch day. This is cool. I don't know if I've ever done one of these before. I'm your host, Jeff Welton. Knock on wood, I got a whole bunch of people smarter than me, so that's probably good for all of us. We've got a bunch of the engineering team, and we're going to talk about this shiny new rack mount FM transmitter product. Okay, before I get started, there is a little bit of housekeeping. There is a question section in there. You can go in, type your questions in. Rather than doing them through the session, because we've got a lot of stuff to cover in a relatively short period of time, I'm going to leave about 10 or 15 minutes at the end. So type the questions in whenever they come to mind, and then we'll hit them in sequence at the end. If there's anything we don't have time to cover, we do have your email addresses. We'll certainly respond by email, but by all means, throw them out there as you think of them. If you are an SBE member, completion of a Nautel webinar does qualify for half of a recertification credit under Schedule I of the SBE's research schedule, so jot that down wherever you keep track. All right, moving forward. So today, as I said, stellar cast. We've got a good chunk of our engineering, I'd say a good chunk of the engineering. We got all the important people, all right? Almost all the important people. We had to leave some out because we just didn't have room on the page. But starting it off, we've got Mr. Etienne Guillemont, who is the VHF design lead. And Etienne, you're kind of the guy in, I guess, I mean, it's really a team thing, but you'd do a lot of the decision making when it comes to this stuff. Now, moving on from there, we've got Mr. Matt Hurden, product manager. And I don't know, Matt's actually sharing a room with me here. Well, not, we're in the same room. So we'll be muting a little bit so we don't create too much echo for you. But so Matt, you're the project manager. I get it wrong every time.
Product manager. Yes. Good morning. Good to be here.
All right, moving down, we've got Justin Jameson, one of our engineering technologists, and Justin has been a wealth of information on this project. Justin, welcome.
Thank you very much, Jeff.
Oops, and I am clicking buttons. I got to stop doing that. I'm moving back and forth as I try to get to the screen that's got everything on it so I can see what I'm doing. Anyway, and last but absolutely not least, we've got Mr. Scott Melvin. Scott, thank you for being here. And Scott, I forgot your title and I can't see it on the screen right now. So I'm going to get you to dictate that for me.
Thanks, Jeff. I am the embedded systems lead for Nautel.
And so now embedded systems, just hit me a bit on what that part does. I mean, because these days there's a fair bit of computerization and software involved.
Yep. So basically it's everything, any circuit card you see in there sort of falls under our team's purview. So everything from the exciter to the controllers, it's all us.
Excellent. All right, so moving forward, we do have a shiny new product and we're really excited about it. It's building on the VS series, and the VS series, if you remember, was introduced around about 2010, so 12 years ago. It was kind of a departure because instead of typically low power transmitters were, you think of the Crowns and the Becks and the RVRs and all the ones out there, they were built to be small, they were built to do a job, and some of them did it pretty darn well. But they didn't give you a lot of the feature set that you could get on the bigger transmitters, the advanced monitoring, control, instrumentation, things like that. So the VS kind of brought that, I guess, call it big transmitter functionality to a small transmitter in a reasonably cost-effective package. So in the years since then, we've shipped about 7,000 of them. So we really want to thank all you folks for your confidence in us. I know we've worked hard to earn it, but it's really been, we're grateful for it. Let's put it that way. So a decade later, we've leveraged a lot of the technology. We've changed, I wouldn't say changed, improved. I mean, it's constant. One of the things we've really always tried to work on is listening to user feedback and adapting things, improving things, both in the way we build stuff and what it does, and how we reach out from, how we use the information from you folks on what you actually want in a product. And so that's what this is leading up to. There's a bunch of features. I'm not going to bother reading the screen. You will see all that as we go along. As I said, we've got a limited amount of time. For maybe the first time ever, I've actually got a clock in front of me. And we'll see if I actually even come close to hitting the target on that one. So what do we have? Well, I made the joke in a marketing meeting or a meeting not long ago that we should say it's new, it's blue, it's coming to you. But that's exactly what it is. It's the VX series. Want to welcome the VX series to our product portfolio. This is basically what you're looking at. The goal was to keep it compact, efficient, and affordable, and a little easier to do some maintenance stuff on. You'll notice a few things that have changed, and again, we'll touch on those as we go. So one of the first things that we try to hit on, and Etienne, I'm going to get you to talk to this a little bit, but easy service with the accessible design. You've done a lot of work, and I know there's some more slides later on about modeling, but talk to me a little bit about how the design layout worked.
So the layout is sort of efficiently laid out with minimal wiring. We've reduced wiring on power supplies. There's, of course, front removable power supply. The amplifiers are accessible, and we'll be talking about this after. Solderless amplifiers. Everything's top down, accessible, very easy to service fans and fan filter. So as you can see, it's a clean design, one layer, everything from the top. So it's a vast improvement over some previous architectures.
Well, and that's one of the things that you mentioned there that I really want to strike on. So we're not talking like to get to a power supply anymore, sliding it out, removing the bottom panel, and basically standing on your head in the rack to try and get it apart. So that is just, again, it's I won't say a big departure. I mean, keeping stuff accessible has always been a goal, but we've really put a lot of work into the layout of this. And Matt, maybe you could talk to that a little bit too, because I know you've been involved. This project's been a few years in the progress. So, you're, as I say, you're the guy that herds the cats. What's the process for that?
Well, a lot of times we've listened to a lot of the customer input. And we've realized where the pain points are. So with the other transmitters that we've had over the years, we've collected that through our support team and listened to those. And that was how this whole project started, was by listening to what had come through support. So that has been a big factor in designing something that meets the needs based on the customer's input. So it's been a really good journey.
Awesome. Now, again, that was sort of one of our fundamental goals was to make it easy to work on, and to say this will be a learning curve. There we go. But one of the things that we have changed too, and I'm going to get Etienne to talk to this one a little bit too, was the solderless PA replacement. And we're not talking solderless FETs, right, ET? We're talking the PA pallet itself.
That's right, the PA pallet. We've only got a DC connection. The RF and bias come in on a single connector, and we've got a connection on the output that's doable with a regular Phillips #1 Phillips screwdriver. So you can remove the entire PA with a single Phillips screwdriver. No soldering required. So that's a new thing, and it took a bit of work, but I think it's going to be worth it.
Right, and Justin, I'm going to drag you in on this too. I know there was a fair bit of talk about fans and filtering, and so we've got something again that's relatively, and we're not. I got dinged on Facebook a little while ago about the Allen keys in the VS series, or the Allen screws, even though we do provide the Allen wrench, but this transmitter is designed with a little more commonly available hardware too, correct?
That's absolutely true, Jeff. We know when it comes to serviceability that a serviceable product can't be so if you need to have a master toolkit in order to access it. So we've really tried to reduce in this product everything down to a #1 Phillips and make it very accessible. So filter washing and replacement is accessible through 4 Phillips screws. Fan replacement is all just Phillips screws, and they're all right out of there. And another big substantial improvement, obviously, is the replacement of the PA power supply just by sliding it in and out of the front of the chassis.
Yeah, and that's a big deal. I know that's something that we've been asked about in the past several times, and so we'll talk about the power supply itself in a little bit as well. But just the front access, you're right, that is huge. Now, the other thing is weight. I mean, a VS 2.5 came in 65 pounds, maybe even a little more, I think. Whereas the VX2, you're talking 24 pounds. Can you talk to some of those changes a little bit, Justin?
Yeah, so obviously when you're talking about a rack mount product, weight is pretty substantial. In terms of a lone station engineer working at the site, being able to lift and remove and both insert the transmitter into the rack is a fairly substantive task for something weighing 65 pounds. You're talking closer to a 2-man lift there. So we really tried to, one of the major design goals was to reduce the amount of weight and kind of make a more easily handleable product. And that also is a major benefit to everyone who touches this product, from our production folks through to myself when I'm working with it in the lab.
Very cool, thank you. Moving on a little bit, again, the power supplies, we talked about that. And Etienne, I'm going to get you to talk with a titanium grade power supply. I know, again, there's a slide further on that talks about it some more, but what is the variable voltage titanium? What's all that mean?
Okay, so titanium grade is, I guess, one step up from platinum. It's got 96% efficiency over a broad range of its load mapping. And in this design, the power supply was customized for our load line and our amplifier specifically to have high efficiency. So this power supply and the whole transmitter maintains high efficiency over a wide range of output power due to the variable voltage design. And it's customized to the higher voltage FET that we're using. So it's specifically paired with our amplifier, and so as a package, it runs very well.
Excellent. And that's one of those situations, and I'll give an example. I know a VS300, for example, we just got this data about a week ago, I guess now. And I mean, you're at minimum power. When you're down into the 10% range, you're just into the barely 10 to 11% overall efficiency. And you're getting much better numbers with these guys at 10% power. Is that correct?
That's right. There's 2 different power supplies in the family. One is from 18 to 53 volts, which is more optimized for the lowest power. The other one is 23 to 65 volts. And yeah, we can get nearly to minimum power just with voltage control. We only need to, at the very extremes, do a little bit of ARB drive back off. So that's why we can maintain good efficiency over a wide range.
Excellent. Moving forward to the exciter, and Scott, I'm going to bring you in on this one. This thing, it's kind of cool and a little bit, I guess, intriguing to me. We've gone a little away from packaging everything onto one board and added a separate analog audio card. And that's cool. And then the dual processors. Talk to me about that, because we're not using all that processing power at the moment, are we?
No, not right now. It's a dual core DSP with an embedded ARM processor, so we're not using a second DSP right now. It's there for future development and expansion as we move forward with the product line. So we've tried to be a bit more forward thinking in our design so that we can expand as we go along. So.
Now, what was the reason for separating out the analog audio card?
Just partly better performance, so that we're isolating it more from any of the RF side or any of the control side, so that we can easily digitize it immediately. Also, if there's ever a failure, obviously, if you have like a lightning strike or something that damages some of your cabling on your audio side, it's a smaller card to replace than trying to replace an entire exciter at once. So.
Right. And I mean, I was making the joke, it's still XLRs, which are a pain in the rear to remove from a rear panel, but it's a whole lot, again, as you say, simpler when it's a small. So coming back to the easier for maintenance and long-term support. It just
far less screws and pins to remove to get out just the analog audio cards and take out the entire exciter and all of its connectors too.
Right, exactly. Thank you. So we do still have the Orban inside option, folks. I know that's been incredibly popular. I don't know the exact percentage of VS transmitters that go out with it, but it is significant. And so we've ported that functionality over to the new box, and just wanted to let you know that as well. This gives you basic 5500 Orban 5500 equivalency on a left-right AES. It does not do composite clipping, so it does use the transmitter's internal stereo generator. So again, that's pretty much the same as we do in the VS, and it's worked really well. So it's been nice to have that. The other thing you'll notice as we go along, you'll start seeing the remote user interface. And Matt, I'm going to get to talk to you, and again, we're going to come to it a little bit, but the new AUI is HTML5 based, so we can pretty much use it in on any device with a web browser, correct?
That's right. Yeah, and we're looking at the audio processor interface here page in the settings on the new AUI. It's HTML5 and it's designed with responsive design, which means it'll run desktop, tablet, phone, the whole range of devices. So as long as it's a modern browser, you'll be able to access the AUI. It's pretty sweet.
So that was just like I said, that was a little side note, but John White's sitting on an airplane somewhere, so he's not able to scold me for wandering off script like I could be scripted. So getting back to the FETs, again, solderless PA replacement. Now, in another departure, although I guess we typically don't recommend it, you could, Ken, you could replace the FET if you so chose, correct?
You could, because there's no coax cable balun soldered on top of the leads. However, it's recommended to replace the entire amplifier, but that for people that want to attempt it, it could be done, yes.
Right. And now we've got a note here that the PA is paired with filter, and you told me a little bit about that the other day, and it was kind of cool. So if I could get you to sort of expand on that a little, please.
Yeah, so this architecture, there's a low pass filter that is sized for the amplifier for up to 1200 watts, and that is consistent across the whole family, which saves on some uncertainty. It basically gives a more consistent power and efficiency for the amplifier regardless of the system it's in, with the harmonic terminations presented at the drain of the device. It's better for EMI and all sorts of things. So this is a new architecture. It's better for the designers because it's one filter instead of 5 filter designs. So this was a lot of work, a lot of sophisticated design modeling to get this to work, but it's great. It's a well shielded, very effective filter.
Cool. And high directivity coupler, what's the benefit of that?
So, of course, directivity of a probe is one of the toughest things to do. High directivity, it's a metric that is basically a fact. It's the separation between forward and reflected power, and with poor directivity, you can have into VSWR, you can have high error. This probe is in 32 dB plus directivity, which I haven't seen anything in this topology of that high directivity. So what it ultimately means is that you have accurate metering, as accurate as you can get relative to a calibration, even into VSWR. So So you're getting the as close to the true power out as the meter as the transmitter thinks you're getting.
That's a good point, because as typically, historically on a lot of boxes, as you start to see the reflected increase, you can just assume that your forward power is no longer accurate. And so this is good to, just to be aware that it is going to be pretty bang on regardless. So yeah, that is kind of awesome. Now, this is something else where you folks asked for it and we were listening. Solderless dedicated interlock. So you remember on the VS and some of the other boxes, the interlock is your jumper pins 19 and 20 on the top connector on the bottom row of it. Not that I've got that memorized, but if you ever needed to wire in remote control or anything, then you'd have to disconnect that connector, which of course would open the interlock, take you on the air, off the air. So now you've got the ability to leave that in. It's its own discrete jumper. So that's a very much, I don't know who came up with the idea, but thank you all very much for that. Yeah, that's a big deal. And there was a conversation about one of the interlock jumpers. Again, Facebook groups. I get more feedback from Facebook these days than I think I get from my email. So that's cool. Now, I'll try to read. See, this is why I don't read the screen. I can't read. But the color display, Matt, I'm going to get you to talk to that a little bit, because there was a lot of back and forth in the early days about whether we should use a touch screen or not. And ultimately we decided no touch screen, so we're not getting inadvertent trips, and with the push button knob and dial to do the controls. So talk to me about that a little bit, if you could.
Sure. So yeah, in the early days, we kind of cast the net really broad in terms of what we would consider, and obviously with touch screens on phones and things, that was an idea, and so we investigated that. And in the end, we realized that the best thing that we could provide was a graphical interface that was as big as we could make it, that would fit onto a 2RU system, but it had to be reliable, robust, and be able to handle all the temperature ranges and things like that. And then a control system, which we'll have a closer look at in a minute, that was straightforward to use. And so this is how we landed on this. We wanted to go bigger than we've had on our previous user interfaces, like on the VS, where we have the little crystal fonts display, and to just make it more graphical. So with this one, the goal is to be able to have it so that you can be a fair number of yards away from the system and still know what the forward power is and that everything is fine. So it's about being communicative when you're local to the transmitter and having the usability. So it's a lot about user experience and things like that. And so there's a lot of technical conversations went into it. And so we're very pleased with the results that the technical team have pulled together for this.
Excellent, thank you. And now, one of the other things that I see here, and Justin, maybe you can talk to that a little bit. I see two green lights, and I assume they're not always green. I hope they're green when they need to be. But what's the rest of the user experience there with respect to controls?
Yeah, so that's a really interesting highlight, Jeff, is we actually found a key switch with both a red and a green LED, so they toggle between a green state and a red state. And those two LEDs / buttons, they're a combo unit, are for controlling via the top one, your RF on/off, your RF state, and the bottom one controls your remote status. So whether you are remote on or remote off, which is to say local mode or local only. So from that perspective, we've actually got two filters in those keycaps that are sensitive to the wavelengths of the LEDs. So when they're lit green, they show on, and when they're lit red, they show off. So that was something that we wanted to make it very easy for the customer at a glance to observe the status of their system, and to provide that dedicated control so that you're not fumbling around for a combination of buttons or keys or navigating through our user interface to do something that should be very quick, like turning RF on and off.
Excellent. Now, the other thing I see over to the right of that is a little fault light, and we've kind of simplified and just gone with one sort of master something's wrong alarm there. Is that about right? And then you go to the user interface for the rest?
That's correct, Jeff. So based on what we took back for feedback from VS, we've had a lot of questions and comments on the array of LEDs and colors and states there. So we wanted to simplify things. So we've boiled it down to a red fault LED. If the LED is lit, you should check your transmitter and check your logs and your active alarms. If the LED is off, your transmitter is in a good state and you're operating as intended. We've also, to go with that, reevaluated all of our various alarms to make sure that we're not exposing any nuisances and alarms where we shouldn't, but that we're actually doing it as a value add to the experience of the customer.
Okay. And further to the evolution, and Scott, you can talk to this, I think, a little, we're SNMP V2C compliant on this one, yes? Obviously,
That's
it's
the
on the
intent.
slide.
Yep. Yep.
And I mean, again, with the DSP horsepower, if down the road you chose to change to later versions or SNMP evolves or whatever, then that's I say it's only a few lines of code, but I'm sure there's a lot more to it than that.
A few more than just a few lines, but yes, it is all code, so it's something that we can upgrade as we go along for sure, and it will probably be roadmapped soon enough anyway.
Right. And that's one of the other things that's worth mentioning on this, where I hate to say software-defined transmitter, but it's to the point that if we do something and you see it and you think, wow, it'd be really nice if they did this, then it's something where getting the user feedback is critical, correct? Because then we've got the ability to sort of add those things, and you know,
Exactly,
within reason.
Within reason, yeah. As long as we have the hardware to do it, then we can. Software is the easy part. I say that jokingly.
Well, again, it's all kind of relative. So there's a close-up view of the user interface. Now, Matt, I'm going to ask you about this, but on the user interface, like I'm looking here, and we've had this. I'm old-fashioned anyway. And we've had the discussion about icons, and I've grudgingly accepted that once I know what they mean, that they're a much easier thing to, at a glance, understand. What level of configurability do I have with this, or is what I see what I get?
So this is the top level dashboard. So when the transmitter is running, if you're doing nothing, this is where you would go to. This is home, like a home page. And this reflects what we're doing on the AUI remotely. So the icons used on here are the same as the ones used on the AUI. So as soon as you've kind of got used to those, you'll be able to know that, you know, the big one is forward power, the one on the bottom right's reflected, and then there's temperature, and then there's modulation. And then from here you navigate into the rest of the settings and values and data that's viewable through the user interface. Along the top we got information about you know, the call sign that you've set and the set point and the forward power and the time. So and then of course the preset. So there's indicators along there as to what you're running and how you're running it.
Excellent. So yeah, that makes it, again, at a glance, what I've got and where I'm going. So thank you. All right, clicking on. And again, these are the buttons, and that's a much better display of what we were describing before. Now, I see, and I'll ask the question because I don't know the answer, but the USB, I'm going to throw this out there. Let's pick a target at random. Justin, USB, what's that for?
Yeah, so anyone who's familiar with our previous products, we've had the opportunity to flash and upgrade your software over USB in the past. And that USB port on the front is performing the exact same options that we've had on our USB port on the rear. So what we wanted to do was to expose a USB port on the front, because we know that when you're in a busy rack with a bunch of connections and you know, different coax solutions in the back of your rack, getting at those USB ports is not always the easiest opportunity. So on the front panel, where we can expect things to be much clearer, it allows the customer to really get at that and use that port just as they would any on the back.
Excellent, thank you. So again, I'm going to bring it back to Matt for a moment to talk about the user interface with respect to externally. And I mean, it's basically the same AUI too that we're moving toward with everything, correct?
Yeah. So the new AUI, which obviously replaces the old AUI on all of our transmitters, gives us a one code base for every transmitter that we do that runs an AUI. So when we make updates to it, when we make improvements, it gets rolled out to all the transmitters. So whether you're working with a VS or a GV or the new VX, it's the same user interface, and it gets all the updates to it if appropriate. So feature-wise, there may be some differences, but those are managed through product configurations. And so this is the homepage, and you can see those same icons in that status bar in the second white line below from the top. So you can see the forward power, etc. So that's basically that. And if you click through to the next step, you'll see some of the highlights of it. So it's HTML5. It's got a brand new operating system. So we are actually upgrading all of the transmitters with the latest technology, and has all the standard things. So some people may not be familiar with our AUI, but it allows you to create presets, unlimited number of presets essentially, notifications for email if there's a fault, a scheduler for presets, control your SNMP, a number of reports available. We've also got a brand new phone home, which allows our support people to help you determine what's going on if you run into any problems. And as I say, it runs on any modern browser, and has substantially a lower bandwidth usage than the previous version. So it's a pretty amazing piece of kit.
This is where I click the slide ahead because it's like I'm looking at the clock going, okay, that's enough. But yeah, there's a lot of really cool stuff. The evolution, and this is one of the other things. We've had a lot of situations, and I know, Etienne, you can talk to this as well. But the VS, we went from 300 to 1 kilowatt because it was the logical evolution for combining. And we've developed a lot more options with the VX series. Sorry, that was more just a discussion for Etienne. Like again, more power levels available.
Yeah, that's right. We've been studying the market, and we want to have more offerings that are customized to what people need, and they're not paying for extra power overhead that they didn't need. So these were the sort of optimal power levels that we've found, and we're filling up in the blank spots, I guess. So much more flexibility and options for the customer.
Right, and you had mentioned earlier that different power supplies, of course, I assume for the lower power ones that you don't need the same amount of horsepower.
Right.
And amplifier count different as well?
Yes, it's a single amplifier from 150 watts to a kilowatt, 2 amplifiers for the 1.5 and 2. It's a lower cost, lower power supply for the 150 to 600, and a higher power supply for the 1 to 2. So we try to optimize, as minimalistic as we can be to optimize,
right.
cost.
And again, I mean, and this is again a question I don't know the answer to, but what's the nominal, I guess, power capability of the amplifier we're using?
The amplifier is capable of 1,200 watts into a good load, actually, it's capable of probably about 1,050 into any 1.5 to 1 VSWR. So all of these transmitters are rated like we always rate transmitters. The nameplate powers into 1.5 to 1 VSWR at all phase angles, and plus 10% rating into 1.2 to 1 VSWR.
I guess that was, yeah, the point I was getting to was we design a fair bit of headroom over and above. So if you've got an example, a 2 kilowatt TPO requirement, then your 2 kilowatt transmitter is not going to be running right hard at redline. There's a little bit of design headroom built in, correct?
Absolutely. That's why we needed, an amplifier that can really do 1200 watts and run up to 60 volts if needed.
One of the other things, and I'm going to keep you on the hook for this one too, because I know this is something that you've been pretty excited about, and it's just a really cool evolution in design and modeling. And so talk to me a little bit about some of the design tools, I guess, that we've got these days.
So we've got a full suite of, it's called ANSYS, and that includes a full computational fluid dynamics package for thermal modeling, as well as a full finite element analysis, electromagnetic modeling set, and those two can couple together to do RF and thermal co-simulation. So we have a very experienced mechanical engineer helping us do who's done thermal design his entire career, helping us with the CFD and the thermal modeling. And we've in a small box, you have to pay very close attention to everything you're doing thermally. So every subassembly of this has been modeled thermally, the entire system. It's optimized for airflow, minimum optimal airflow. We have variable speed fans. In one of the earlier images, we were showing this grill. I don't want to talk about it too long, but even the grill is specialized. It has 85% open area to reduce restriction on the fan. The fan is optimized for the impedances in the system. So I could talk about this all day, but needless to say, it's been very carefully designed thermally.
Yeah. Now, one of the other things, and I see that John put the note in there about the MTTF. For anybody who doesn't know, that's mean time to failure, or theoretical design lifespan, I guess, when operated according to spec. And 250 million hours, that's a significant chunk of time.
Yeah, so keep in mind that's an electromigration MTTF number based on the physics, and that's normal operating temperature and everything. But even in the extremes, we're talking very high, multiple dozen millions of hours. And part of the reason is this is a very robust device. That's a 65 volt device that from the manufacturer is designed for 1600 watts. We're using it at 1200. So there's a lot of headroom built in on that device. And we're running, and the design thermally is keeping the junction significantly below TJ max. These are 225 degree TJ max devices, and we're running at 150, 160 typically. So that's why you get such a high MTTF calculation there.
Yeah, good deal. And again, what it translates to the end user is, all things being equal, these should last a good long time, which was kind of the goal. And this was the electromagnetic modeling you were talking about, and you've got the image of the 2 kilowatt combiner there.
That's right. There's on the left, top left, that's the directional coupler I mentioned earlier with the high directivity. Without a tool like this, I don't think there would have been a chance of optimizing to that level. If you zoom in and look at the fields, you have to have extreme isolation there to achieve that kind of directivity. On the right, showing a meshing of the two kilowatt combiner. So every subassembly in there has been designed, like the low pass filter, anything RF wise has been carefully designed. And what it allows us to do is optimize way better than you could ever do without a tool like that. So you're getting the best efficiency out of it, and everything you can do in that amount of space you have to work with, basically.
Right. And again, as you said before, when you're condensing everything, then knowing what every piece is doing, not only in itself, but with relation to the others is critical. Don't need to beat the drum too much on the the design approach, except for the fact that, I mean, these are North American built, designed and supported. You know, we do the support for, well, you know, we're still supporting stuff we built in the early 70s, I think, was some of the first navigational gear that's still on the air. So that's really kind of cool. I know support still gets the occasional call on an NTB 200 50 watt AM transmitter we built in 1973. So that's, again, pretty neat. Spec wise, the spec sheet, and I'll let Matt talk to this in a little bit, but the spec sheet will be available, I am going to guess, before the end of today. And, you know, so Matt, while I've got it up there, just hit me with it a bit. We're going to run a little short on time, but again, it wouldn't be the first time.
I'm going to say just read the numbers because they speak for themselves. Justin's the one who could speak to them in more detail, but I think in the interest of the time, I think these are pretty good specs. So we'll make them available shortly. And so, yeah, I think we're doing very well in this area.
Now, let me get back, there we go. One other thing that, and I don't remember if it's on a future slide as well, but the output connector options. Justin, I am going to put you on the hook for output connectors. So what are we doing for output connectors?
So for the 150 to 600, it's going to be a type N connector. And then from a 1 kilowatt to 2 kilowatt, you're going to be looking at the 716 DIN that you've got there.
Very good. As I said, we're going to, in the interest of time, we'll high speed through the power summary. But again, we've got a whole bunch of additional power levels available. You can see the efficiencies. I mean, especially on the 1 and 2 kilowatts, you're upwards of 75%. So just the again, the flexibility, I guess, having the choice is really cool. I mean, that's something that we've been looking for quite a while. So it's really nice to have that. Obvious, we've got the, and I saw it in the questions already when I'm glancing through the question about LPFM. The 150 and 300 watt currently are LPFM certified. There has been some question about the 600 watt. If LP250 ever happens, then obviously that will be a step we'll have to look at. At this point, we didn't, because there's just no requirement for it at the moment. Into a single bay with 1/2-inch coax, even at the maximum length, or maximum height possible, a 300 watt transmitter will be way more than adequate. So typical uses for the modular lower power or the rack mount lower power translators, SFNs. The lightweight will make these ones much more, I guess, applicable with respect to emergency transmitters, because you'll be able to move them around a whole lot more, you know, with the, again, the 2 kilowatt being significantly less than the VS2.5 weight wise. So that's something that, again, we're really excited about. So summary, as I said, a bunch of power levels, easy display, easy to fix if you ever need to, easy to maintain, which is huge, especially in a small box. Lots of features. I'm not going to read them all off. I like the pre-order now for shipment. But yeah, the availability is Q4 this year, so the October to December timeframe, and we did get some pretty good stock built up for parts, so that's also pretty cool. Standard 4-year warranty, obviously the best support. I may or may not be a little biased there, but hey, you know, I think we do pretty good in that regard. So excellent team, and we've got some of them here at NAB with us. It's going to be a good show. But one more thing, and this is where I mute my mic and let Matt talk for a couple of seconds.
So yeah, so we didn't stop there, and our tech team has pulled out all the stops, and they've done some fantastic work over the past year. So we're also very pleased to show that we are extending the range up to 5 kilowatts. So this uses, again, We can see that, Jeff, that little. And so that's what we're introducing here is models up to 5 kilowatts. I think we can go to the next slide as well, and you can see that there's two components to it: the upper portion and then the power amplifier below. And the models that we're including for this one are 3, 3.5, 4, and 5 kilowatts. So that's a pretty exciting setup. I think we can go to the next slide as well. Separate exciter controller, and the reason for that was that we wanted to make this so that it's again, it's manageable by one person who's putting things into a rack, as Justin was referring to earlier. So you've got a exciter controller that's 15 pounds, and then the power section without its power supplies is 50 pounds. So it's the same as check-in luggage, and it has all the same really cool design assets that that the team has put together on the lower power unit. And this one will be, we're planning to ship this one in Q1 of 2023. So it's following right on the heels of the up to 2 kilowatt systems.
It had to be me. The first time somebody forgot to unmute, it had to be me. But one other thing to mention is that we will have these transmitters on the floor here at NAB, of course. I mean, this is obviously why we timed the launch for right before the show. So absolutely, if you're in Las Vegas starting Sunday, or prefer, well, you know, come see us at the users group Sunday morning. But on the show floor, anywhere through the week, you'll be able to see VX transmitters live and in person. And I'm sure, let's see, we've got a few of y'all are going to be here. I know Matt's here because, again, he's sitting right beside me, but we'll be able to show this stuff off in person, and that's really exciting. So again, lots of new models ranging from 150 watts up to 5 kilowatts, a lot more flexibility and power levels, a lot more portability and lightweight, and just an amazing amount of power. And I guess future-proofing is the phrase I use. And I know Scott had talked to it quite a bit with the DSP course, but absolutely, it's kind of exciting. So this really fills in the gap. Now, we're still going to keep the VS for HD, and Matt, talk to me about that, just really brief, because we are running out of time and we've got a bucket load of questions. But talk to me about the goal for VS.
So the goal for VS and how it fits with what we're doing with the VX series is to sort of continue to be the premium transmitter for HD transmitters, and in the lower power range. The VX was an opportunity where we found the performance was so phenomenal in the analog range, and that's what the design team was able to recognize very quickly with the technology that was available to us when we started doing this project, that we really felt that we needed to optimize for analog, and that's what VX is focused on. So the VS is continuing to perform its function as a premium transmitter that delivers HD radio performance in that range. And then, of course, as you go up into the higher powers, you move into the GV and the MV Lite series.
Exactly. Thank you for that. All right, now questions, and I'm going to leave this slide up here while I click the questions window open, which may or may not display on my monitor. If it does, I apologize in advance. John Van Milligan's busy doing the math on 250 million hours of mean time to failure. So request additional filtering required at the output? No, that's totally self-contained, correct, ET? Etienne?
That's right, yes.
Yeah. How modular for field repair? We covered that. Quieter, there's a question. I know with the VS300, for example, if you wanted to put it in the studio or in a church hall or something, the fan was pretty loud. Now, you mentioned these are variable speed. How do we do sound pressure SPL-wise compared to the old ones, to the VS units?
It's improved. It's 65 or better dBA. It depends on the model. It gets better as you go in lower in power. Also, we spectrally looked at the noise. So the actual, aside from just the sound pressure level, we looked at the nuisance tones and reduced that as well. So there's a perceived annoyance factor, and then there's the sound pressure level. And we looked at both of those. So the fan speed is optimal for cooling and reliability at minimum at a good low speed that isn't overkill. So the variable speed fans is a big advantage there.
Very cool. Now, there's a question about battery, and I'll throw this one to Scott. Scott, so do we have a controller battery in this, and is it easily accessible, or do I have to pull the cover off?
We got rid of the battery. It's a super cap now, so it's self-charging.
Beautiful. So there you go, folks. No battery. That's another, again, just the little improvements like that. Have you figured out how to recycle bad power supplies when they die? That is a topic that we're going to be covering at the users group on Sunday. And for the first time ever, we are going to attempt to stream the users group, obviously. And I'm going to give a quick shout out to the folks at Max Connect, because we're running this instead of relying on Vegas Hotel Internet. We're running this on a Max Connect LTE modem right now. So if we haven't glitched out too badly, that's a good sign. But we're going to use it again, or going to try to use it again at the Flamingo on Sunday for the users group, and we will talk to power supplies on that day. Now the VX2, how many power supplies, Justin, in the 2 kilowatt? That was 2 supplies, correct?
So in the 2 kilowatt, there is a 12-volt low voltage power supply that feeds the different control circuitry, the exciter, and the IPA. But then there's only a single PA power supply.
Right. And William asked, is the power supply built by us so we're in control of our own destiny as far as end of life support? And to outsourcing the power supplies was a conscious decision, I know. And Etienne, I know you were part of there was a lot of thought into that. And could you explain a little of that thought process?
Well, we've been working with Lineage, which changed to GE, which is now ABB, for well over 10 years. And so the power supply, I mean, I'm going to be honest, they can do a way better job than we'll ever be able to do it. Power supply design, I mean, that's what they do. These things have MTTF, a 0.2% annual failure rate for the entire CPE series. They're qualified against a dozen or more standards, put through rigorous tests. These are extremely reliable power supplies. So it's the best out there. It's one of the best power supplies in the world. So it's a premium power supply. So there's no way Nautel, I hate to say it, but we're not going to be able to design ever something that good. So we don't specialize in power supply design. I'm sorry.
Right. Well, no, it's like one of our guys said years ago when I was talking to him about it. He said, I could design one this reliable, but it would either be 10 times as big or cost 10 times as much.
That's right.
And, so that's the deal. Now, there's a question, are there any plans to be able to run, so 120 versus 240 volts, what runs where? I guess is the better way to ask that. And I'll throw that right back at you, E.T.
Well, you're really testing me on that one. I believe the entire range can go run from maybe not 2 kilowatts. Justin may have to help me out on this. So we'd have to
I think I can grab this one. So the entire range has universal input power supplies. So we can run full power in the range of 150 up to 1 kilowatt off of a nominal 120 volt North American power supply. In the 1.5 and the 2, they need a nominal 208 or 240 volt power supply. However, they can run at a reduced output capability off of 120 volts. If you're caught in the situation where you've only got a regular wall outlet and you've got to plug it in, it can do that.
Okay, so now the coolest, and you said the 1 kilowatt will do 120 volt now?
1 kilowatt will do 120 volt. We've managed to get our efficiency up high enough that we have enough overhead on that power supply at its low kind of voltage configuration that we can achieve a full kilowatt.
Cool. A couple of questions about new AUI versus legacy and other model transmitters, and not germane to this conversation, but again, pay attention to the NUG. We'll be discussing that there as well. I answered the question about HD. So the VX2 is rated at 2 kilowatts. For the folks that need just a little more power, what's the option? VS 2.5 right now, and then the 3 kilowatt going forward, correct? I see Justin's nodding his head, so that's
that would be our goal there. Yeah, is the 2 has its plus 10% rating, so you can get up to 2200 if you're operating into a good load, which I think most people are on most days. However, the replacement for the 2.5 truly will be the 3 kilowatt once that's released.
Right. So one other question in here, and we're running close to the top of the hour, so anything I don't miss, like I say, we'll hit with email. But what about frequency response of the sample port for harmonic and IMD measurements? Because I mean, traditionally, we've always said don't use the sample port for taking harmonic readings because we won't guarantee the linearity, and we don't. I think we do publish the curve now in the manual, but so Etienne, you're kind of, I see the eyes, you're paying attention, but what about with the higher directivity, sample port wise? I don't think we discussed that much.
Well, the RF monitor port, it's a coupled line directional coupler. It has a pretty flat response, compensated response. Of course, like we say, it is an RF monitor. It's meant for driving modulation monitors. We have a well-defined response for it. There's no resonances or anything like that. So, but in terms of looking at spectrum, there is going to be a 60 dB per octave or so coupling factor there. So, but however, it has been compensated a bit. So, bottom line is it's a pretty flat response. But if you're going to do any careful measurements on spectrum with it, you'll need to put in the compensation factor for the increased coupling with frequency or the variance there, right?
Yeah.
So.
Oh, and obviously that this is put in as a question. I think I can answer it, but they are frequency agile, so you just basically dial in the frequency. Can you do like we can with the other transmitters? You just program a preset for specific frequency. Say I'm using N+1 and wanted to have multi-station backup.
That's correct.
I guess I should have asked somebody or targeted somebody on that, but yeah, thanks, Justin. Exactly. All right. Questions on main voltage. Does it do FSK ID? Justin?
Yes, I do believe we've nod your head. Yes, Scott, if that's correct.
Yes.
We do have
there.
FSK ID.
Yeah, the translator functionality is there for FSK.
All right. And Vaughn has asked about availability. So we mentioned that shipping, so basically you can order now for shipping Q4 up to the 2, and then first half of next year, I'm being a little pessimistic because that's my nature, but first half of next year for the 3 to 5 kilowatts. So yeah, absolutely, we've got the ability to handle that. Let's see, remote control question answered. Power supply question answered. I think we've got, I know I'm missing some, and as I said, I will give some emails out to anybody that I've missed, but at that point we've hit the hour mark, and guys, I just want to thank you all for taking the time to be with us today. I mean, I know you've got a bunch to do, so Etienne, Matt, Justin, Scott, I really appreciate your time. Thank you very much.
Thank you, Jeff.
Yes, thanks, Jeff.
And folks, as I said, we're here all week, and next week we're in Las Vegas at NAB. You will see these coming to state shows near you in the very, very near future, because I'm pretty sure all the sales guys are going to be scavenging the ones out of NAB and taking them onto the show circuit with us over the summer. So any questions at all, reach out to your sales guy, and by all means, let us know what we can do to help you, so to speak. This webinar will be archived. You'll be able to find it on the webinars tab of our website or through our YouTube channel. There's a VX series product page, and Matt has told me that about 5 seconds after I hit the hang up button on this webinar, that page will be live. It may not be 5 seconds, it may be 5 or 10 minutes.
I just published it as you spoke.
There you go. It's live now. So on that note, folks, I want to thank you all very much for spending the time with us. We look forward to seeing you on the trade show circuits and as we make our way out and around. And thank you very much. Have a great day. Bye now.